Hello, and welcome back to Mechanical Engineering Practice and Graphics. We are in week number 3, and therefore we will be covering the third chapter in the book. This week we have the second homework. I already graded your first homework. You should be able to see your grades in Blackboard. And I would like to take this opportunity to do a friendly reminder that next week we have a quiz. The quiz will be of chapters 2 and 3 from the book. Okay, and I'm gonna start by uh, showing you how to do uh, the last homework. I already showed you how to do the first part, but I'm gonna do a quick notice here that uh, here we have these lines that are called the arc center line or circle center lines. They mark the center of of the arc, the center position of the arc, or the circle, as you see in the other exercises. Now, those lines are just for construction. If you don't have them, that's fine. You don't always have to show them. Also, I would like to take this opportunity to show you how to edit a sketch. If for whatever reason I did this sketch and I need to edit it, I can just come here in this list on the left. And here I have my first sketch. I'm gonna right click on the sketch number 1, and then I have this first option that is edit sketch. Now as you see here, I have my radius, but I don't have any line for construction for the center because I can just locate the center in a line for construction here. Another thing that you would like to have here is activate the view sketch relations. Those are these green boxes in the sketch that shows any relation between lines and points by clicking here, view sketch relations. Okay, I'm gonna do the second one, create new. This one, because in this one I saw most of the problems during the homework. So let's go ahead and do it. First I'm gonna select the front plane. I'm gonna create a sketch using that front plane. Now, the point of having those center lines or lines for construction at the beginning is I want what the computer does with these geometries, it relates every line and every point with this, the origin. Remember that the origin is marked by the 2 red arrows when you open a sketch. And basically this is the point. Down here we have our coordinate system, and these points represents the coordinates 0, 0, 0 in x, y, and z. Now we are drawing in the plane x and y, and everything we do will be in the plane with coordinates c, 0, c equals 0. So the point for me to add that those lines at the beginning is to extend that point. Now I know that anything that is along this line will have the coordinate x equals 0, and also everything that I do along this vertical line that goes through that origin has the coordinate y equals 0. Now if I draw my construction line anywhere else, look that it is blue, and therefore I can move it. And remember that blue means that it's underdefined, as we can see down here. Whereas everything that is black, it's fully defined and I cannot move it. It's fixed. Now there is a trick in which I could just fix this in the space, and it's by adding a relation here, what it's called fix. However, this is a trick, and this is not truly defining the position of this line. If I ask you right now what is the distance between this line and this line, you wouldn't know. And then you will have to add a dimension there, or just to measure that. So let's try to avoid using the fixed relation. I don't like it, it's just a trick. So let's try just to avoid it. I can click on the relation and delete it. And I would think it's better if you define a dimension from the construction lines that you already have, or from the origin to the line that you want to build, and then you add your dimension. That would be better. It's fixed, and I didn't have to use that fixed relation. Okay? So I'm gonna delete this one because I don't really need this line for construction yet. By clicking delete in my keyboard. Now, as you see, this second part is symmetric. I don't need to do the entire model. I just have to do half of the model. And that's what I'm gonna do. I'm gonna place the origin down here, where in the intersection of this base and this vertical line for construction. And from there, I'm gonna draw only one half, the right half. So I click here in line, and I start from the origin. Now, by default, I have millimeters, grams, and second here. Just make sure that we're working in the same units. Also, since remember that we're gonna have a final project that is in groups at the end of the semester, you might all be working in the same units, but also in the same version of SolidWorks. I have version 2019. If you have a different version than the members of your group, they will not be able to open newest versions in the older version. So all of you that are working in SolidWorks 2020, if you can work in 2019, that would be better. Okay, I'm gonna add these dimensions here. Now, this one, I could just define the dimension of this line, and I know that it should be 15, half of this 30. However, I would like to try something different today. I would like to show you that I can define the distance from this center, from this point to the center, but I can do it like if it was a full distance. Now, this represents that this would be like the center axis, or the symmetric axis of this dimension. And here I can define the 30, as you see. It will be 30 from this vertical line to an imaginary vertical line that I will have here in the future. Once this is finished, you will see this dimension making sense. Now I'm gonna define this other dimension. This is 10. The same as for this vertical dimension. And the same for this other dimension. Now I need 40 in the vertical. Now I saw that some of you only define like the maybe the length of the line here. However, look that by doing so, the line is not fully defined. Actually, this point is underdefined and I can move it around. And that's because defining this dimension is not like fixed. I can move it around. So in order to have everything fully defined, it's better to use the Smart Dimension tool. And that way we can have all the lines and all the points black, meaning that they are fully defined. Now, by defining these dimensions this way, look what happens to the parameter of the line. It matches the dimension that I'm requesting. Now, as you see in my mouse, in my cursor, when I move it around, there is a moment at which it becomes with an angle of 45 degrees in the indicator of my mouse, with a small angle in the bottom of the pencil. It's just showing that this line is already at 45 degrees. However, I am gonna do it at a different angle to show you how you can define angles with the Smart Dimension tool. I first click this line, the line that is diagonal, and then any other line. It can be either the horizontal line or the vertical line or even this line for construction, because an angle is measured from two lines, not only one, not only a single line. 45 degrees, and then I saw that another common mistake was defining that the length of this line was 10, and that was not correct. What was 10 was the vertical distance of that line, the vertical component of that line. Now if I measure what's the length of this line, I can use Pythagoras theorem, because I have 45 degrees here, I have this vertical line that is 10, and therefore I know that the other distance here, the horizontal distance here, will be also 10, since we have 45 degrees here. And then I can do a square root of 10 to the power of 2 plus another 10 to the power of 2. That will be the square root of 200, which is 10 times the square root of 2. That will be the length of this line that you see here, 14. Now if I take my calculator, ten times 2 square root, you see? That's the number that we got. Okay. And that will define this line here. Now I need to do this circle. However, something interesting here is that, as you see, this center of this circle, it's aligned with this point horizontally, and it's also aligned with this other point vertically. And actually it goes and matches this line here. So there are two ways. I can either draw a line for construction, maybe a vertical line for construction, from here to here maybe. And I know that my circle must be aligned with that line. So I can draw my circle somewhere, right? But then if I compare this, look that I cannot move this circle left or right, only up and down. And even more, I'm going to define the radius of that circle, sorry, the diameter, which is 10. And look that the circle is still blue because I cannot move it left or right, but I can move it up and down. You see? I can only move it up and down. Now if I leave it there, this is really different to what we have here. And that's because this point it's aligned with this corner here and this other corner here. So another thing that I could do is I can either draw a line for construction here, or I can use the relations tool by clicking this point and the center of the circle, and I can say that they both are horizontal. And then you see that I have here the horizontal existing relation, but also I have the relation here in these 2 points. So it's important for you to get familiar with these relations. There are many relations depending upon if you are using lines or points. And all of them have a different symbol in these boxes. This one means that this line and the center point of the circle are coincident, as you see in the description there. We also have coincident points and lines with the origin and these 2 lines for construction down here. Look that they both become purple when I select the relation, highlighting which 2 entities have that relation. Okay, and all I'm missing is this hole here. Now I saw that some of you did the hole, but it was like either too high or too low, and they did not consider this 15, this distance from the bottom to the bottom of the hole, or from the base to the bottom of the hole. Something to be careful. Because that's a geometric description of this part, and remember that we're doing geometric representations in the software. This distance is 10, and then this distance from here to here is only 5. Now if I leave it there, look that I can move this left and right, and that's because I still need to define this distance to the center. However, I don't have that distance to the center. I have the distance from this line to the line at the other side. So I can define that, or I can define either 1/2 of that to the center. What I'm gonna do is I'm gonna click on this line first, then in the center line, and then if I move my mouse to the right, I have only 1/2 the dimension, or if I move it to the left, I have the full dimension. this. Now that I have 1/2 of the model, I can just come here and select everything, and then I can click here in mirror entities, or not. There was a problem there. I'm gonna click first mirror entities. Now it's asking me which entities do I want to mirror, and then I'm gonna select everything. And then the line or mirror about this vertical line for construction here. And then I can click OK. Now I have some vertical dimensions here, and it says that it's over defined, or I have this alert message here, no solution found. So it means that I need to either delete some relations or dimensions. So I'm gonna start deleting dimensions first. Now I can try to add them again. Okay, this one is defined by this vertical line, this line, and then this 10 and this 45 decrease here, because basically it's with these two dimensions, I'm already telling the system that these two are the distance from this vertical line and this vertical line is already 10. And then I need to define this distance here to here, 30, and that was it. So that was the problem. And if you see, everything is black now, all my lines. Now, the software also recognizes closed loops as closed areas. We have this light gray area, and then we have this dark gray areas too. And what I'm gonna do, I'm gonna click here in exit sketch. I can either click here in the top left, or I can also click here in the top right. And then I'm gonna go to features. Now the first thing is I'm gonna click here in sketch in the list, on the left list, and then I'm gonna click here in extrude boss base. And look what happens. I can create a 3D body out of that 2D drawing that we did. And here we have also a list of options that we can define. I can define blind or mid-plane. This mid-plane means that basically it will extrude in both directions the same quantity, and then we have here the distance that we want to do the extrusion. I'm gonna click 10. And look, we have our first 3D body. Now here on the left, the sketch symbol suddenly changed to box extrude. However, it has like a small arrow on the left. I can deploy it. And then we see sketch 1. And that will be the sketch that was used to produce that extrusion. If for whatever reason I need to add maybe one more hole there, I can either create a circle and create a hole, or I can just modify this sketch. And that's what I'm gonna do. I'm gonna modify the sketch. I'm gonna show you again. I can right click on the sketch 1 and then clicking in this position, edit sketch. Maybe I want to do a small hole here, and then it has a hole there. Or maybe I want to increase the distance of extrusion. So I can, instead of editing the sketch, I might want to edit the extrusion. So I go here and then I right click there. And the first option is edit feature. And then I can increase this dimension. And now it's thicker. So that was the purpose for me of doing this model, to show you the extrusion tool here. Most of the problems that I saw were in this model, maybe defining that 45 degree, or just the circles were everywhere. You didn't really define the position of those circles. Another problem that I saw was some people didn't define the vertical distance from the center of this circle to this line here, or the vertical distance from this circle to the bottom in this model. Those were, I would say, most of the mistakes in this homework. Okay. I'm gonna show you some different controls here. We already saw the mirror entity. Basically, you just model one half of the model, and then you use the mirror entity to create the symmetric portion of that model, or complete the symmetric portion of that model. So we take advantage of those symmetric axes in any drawing, just to draw one half, and then you use this tool. That's faster. And well, now you're only doing one part, but when you're doing an assembly of maybe one car and you need to do millions and millions of parts, well, this becomes handy. You can also do it for 3D bodies, and let's try to do this. Maybe this part is also symmetric from here in the bottom, and you can click here in mirror in the features tab. We have here mirror. So it will first ask us a face to mirror everything. I can define this face, and then the features, I can just select everything. Sorry. And then just click OK, and it will create the symmetric part out of that symmetry axis. That in our case was the top plane here. Okay. So you can do that in a sketch, or you can do that also in a 3D body. You only model one half of that, and then you create the rest of it by clicking in the mirror tool, as we just did. Or for example, this eye, I don't know if you have seen maybe some beams, some steel beams in construction, or yeah, these are used in roofs of in construction. Basically, it's just a eye profile, and then you only model 1/4 of that, and then you use the two symmetry axes to complete the entire geometry. Okay. Let's go in order. Let's use the trim entities now. I'm gonna create a new drawing. And then here in the front plane, I'm gonna create a new sketch. I can just click the plane that I want to use, and then the first option that I have here is a sketch. I'm gonna draw two lines anywhere in the space, and these two lines intercept each other. Now if we go and click this tool, the trim entity, it's like a scissor, and it's right here, trim entities. Look that I have different options here on the left, power trim, corner, and so on. I use most of the time the power trim because maybe I just want to delete one line in this drawing and then click OK. Or maybe I just want to do a corner, so I can do that as well, corner. And then I select this line and this other line, and then I have my corner. Or maybe I want to keep these two portions of the corner. Sorry. And then I just click down here and down here. As you see, I can keep either one top or the bottom or maybe the left. And it basically keeps the portion of the line that I click. I'm gonna delete all of it by clicking delete in my keyboard, and I'm gonna create two lines, but these two lines does not intercept each other. They are like this. And then what I can do is, instead of trimming the entities, I can extend the entities to create the intersection of those two lines. So instead of clicking here in trim entities, it has a small arrow there to deploy, and then I can click the second option, extend entity, and then I select. Look that it's already recognizing that I want to extend this line. So I click first here, and there it goes. It extends the line until it intercepts the other line. There's that control. We already discussed the symmetry axis and the mirror, so I'm gonna skip this until convert entities. I'm gonna do quickly this model and then to show you the convert entities. I'm gonna delete everything again. But I will take this chance to also show you the offset. So let's go ahead and do it together. Infinite. And then another vertical here. And then one circle here. Now, I want you to learn this other option, the offset entity. And basically what it does, it creates a parallel circle or maybe a parallel line to the one that I'm creating. And I'm gonna define, well, 10 is okay. Now you see that it created like this gap distance between these two circles. However, the circles are still blue because I haven't defined any radius or diameter for any of those. So let's just define this one maybe. 100 is fine. And then I'm gonna do another circle here. Maybe, I don't know, 25. I'm gonna place it lower, maybe around here, from a distance of 100. And I'm gonna do the same. I'm gonna create an offset from this circle. Maybe this one is only 5. And then I'm gonna create a line. Look that when I move my mouse around this circle, look, look when I move my mouse around this circle, I have these yellow diamonds showing me the extreme points in X and Y. And when I draw this line, I have this relation here of coincidence, and here that this line and this circle are tangent, meaning that they touch only in one single point there. I'll do the same here. Or actually, let's use the mirror entity. I'm gonna mirror this line about this center line, and then I don't have to do it twice. And then I want to delete only this bottom part of this circle, so I go to trim entities and delete with power trim. I basically draw a line by holding the click in my mouse, and then it deletes that one, and then it deletes this other one, and that's it. And then I'm gonna do a circular pattern. So I'm gonna go here where it says linear sketch pattern in the deployable menu, and then I have the second option, circular sketch pattern. And first it asks me uh, the center of that circular pattern. That will be the origin here. And then I select here in entities to pattern this list. I want to pattern all of this. However, I'm gonna do only 3 of them, as you see here, and then click OK. Now I'm gonna exit this sketch, and I'm gonna do an extrusion of, I can also deploy here this sketch. Now it's asking me select the contours that I want to extrude. So I'm gonna select, not that one, I'm gonna select first this one. Maybe 100 is fine. And just click OK. And then I'm gonna also select this sketch here and create a second extrusion using the same sketch that I already used. But this time in the contours, I'm gonna select this part here, this part, and this part. But this one are gonna be only, I don't know, 25 or so. Yeah. So we have this geometry kind of similar to what we have here in the example. But maybe, hey, I might want to do this, these geometries also in this at this height or in this part. So what I can do, I can come here to this plane, and I'm gonna create a sketch from that plane by clicking here, or you can come here in sketch and click sketch. But what is important here is having this plane here selected or in blue, as you can see in my screen. And then you see that my origin is certainly in that plane. So I'm gonna click Ctrl 8 to align the XY plane. And then I'm gonna use the convert entities tool that we have here. Convert entities. And then I'm gonna select this extrusion, and this extrusion. Okay. And look at what happens. Now I have those geometries projected in the plane in which I am drawing this sketch. I forgot to do also the convert entities of maybe this hole, maybe this circle, and this circle. Click OK, and then we have those circles in our drawing. Now I can exit the sketch, create an extrusion using that second sketch that I did, and it's also 25, but now look that it's going outwards of this plane, and maybe I want to have it in the other direction. So I can either make this dimension negative 25. It doesn't recognize it, so that doesn't work. Maybe I can just drag this to the other side and define the 25, or I can just click here in reverse direction. That's a lot easier. And then click OK. And that's it. So by doing this, we already learned several things. We learned the offset entity. We learned the convert entity. We learned the trimming entities to delete maybe portion of a circle or of an arc. We learned the extrusion. And we also learned the circular pattern of those three holes and geometries around the center of this circle. Okay, let's go back. So you already learned the offset. I already show you how to edit either features or sketches. Remember that here we have, these are my features, 3 extrusions, and I can right click there, maybe decrease this, and also maybe I want to decrease the other one. But also you can also modify a sketch. You select the sketch and then click here in edit sketch, and then I have my sketch and I can modify it, add things. Be careful when you're deleting things. When you're editing a sketch and then you want to delete something, be careful. What else can you do here? Well, something really important. Basically, as you see, it's like a history of the activities that we have done. We started by doing the sketch, then we did the extrusion, then we did the second extrusion using the same sketch 1, and then we did a second sketch. Using that second sketch, we did a third extrusion. But I can go back in time by moving this line, and maybe look that the third extrusion becomes invisible, it becomes inactive. And maybe I can do something first or previous that extrusion, and then I can just move to recover the extrusion. Move this line down again. Maybe, I forgot to add something here. Maybe, I don't know, a hole somewhere. Maybe let's do a hole here. I'm gonna create a sketch using the right plane. Control 8. Just a small circle here. And then exit. And this time I'm gonna do an extrusion, but creating a hole, extrude cut, as you see here, of that circle. And I'm gonna create up to surface, up to this surface. Basically, we'll create the hole from this surface to this other surface. But maybe no, maybe I should use mid plane instead, because I want it in both directions. And then I can move down again this line. Now, what was the point of moving this line up and down, you might ask? And sometimes having geometries in between two actions can help you to define dimensions from those new geometries. And maybe it was necessary to define a length from this hole to this surface here or whatever. So you don't have to do everything linear or oh, I forgot, then I have to delete things and go back and redo things. No, it's not necessary. You can just move this line up and down. And basically, this is something else that I do when I'm grading you. I go and see how was the process that you used to do your geometries, step by step. So there is that. Okay, fillets and chamfers, these are very important. I'm gonna create a new geometry. You don't have to say this was just an example. And using the front plane, I'm gonna create a new sketch. I'm gonna select a center rectangle here. And then here we have sketch fillet, but then if I deploy, we also have sketch chamfer. Basically, these are to soften edges. So here, I'm gonna do it again because I did it too fast. I click here in sketch fillet, and then I select one corner, and I can increase the radius of the fillet. Or I can also do a chamfer. Let's use this portion here. And basically I can define a distance or maybe an angle, maybe 30 degrees or so. Or I can just modify this length here. Now you see that these two have like these two red circles there. They mean that these two dimensions are related. So I can do it this way. I'm gonna exit and create an extrusion out of that. It will really matter how much. Or you can do it in a 3D body as well. If I remember where it is. I always have some trouble finding that. It's right here in fillet. Again, we have fillet or chamfer. Maybe a fillet will do. And in this case, you select one line, and then you can increase this dimension. It can be constant along that line, or maybe you want a variable size, or you just have to define two faces, maybe this face and this face. Sorry, I have to delete this one and select it here. So you select the first face here and the second face here, and it will automatically define the fillet that joins those two faces. Or I can do, instead of a fillet, I can do as well a chamfer, maybe here. Again, we can define the angle and then a distance. I can also, I'm gonna create a new sketch. Control 8. Another rectangle, but here maybe. And then another extrusion. And what I wanted to show you is that I can do like an arc to soften all of these edges by clicking in fillet. And then here in foreground fillet. So first I select this face here. In the center I select this face, and in the other side I select this other face. And it will create this rounding around all of those three faces to soften all of those corners. So now you know how to do fillets and chamfers in Sketch or also a 3D body. Here are some examples of what we just did. We already did some patterns. We did the circular pattern. The linear pattern is the same, but just like in a grid. And I already showed this in the last week's video, so I'm gonna skip it. You can do the same in 3D. It doesn't have to be always in 2D. Okay, revolutions. This one is very interesting. Let's try to create this bat, or sort of bat. Let's create a new file, new part. And in the front plane, I'm going to create a new sketch. Again, a good practice, horizontal, infinite length for construction, here. And also in the vertical direction, here. Okay, how does a revolution work? Basically, we have one profile that turns around an axis, and that axis will be this center vertical line that we have here in dotted line here. And basically, it's like when you use a mill, it goes around. This shape goes around that line, creating this shape, this bad shape. So maybe I just do a line here. And maybe another line somewhere here. This is too long. You don't have to do this. This is just to show you how a revolution works. and then I just close the loop here. And then I have my bat shape there. Then exit. Now this time, instead of creating an extrusion, because if I do so, look what happens. It will not be a bat. Maybe a badminton. No, badminton. What I have to do is click here in revolution, click the sketch, and then I have to select the axis of revolution. That will be this vertical line here. And then I can either do maybe half a circle if I want just half a bat, or an entire loop 360. Well, you know that in a circle we have 360 degrees. And I got the ugliest bat in the world, but well, now you know how the revolution tool works. Now if I ask you how to do a circle or a donut, uh, there are there are differences on doing a circle or a donut. I'm gonna try to explain myself. Let me just create a new sketch here, in which I'm gonna do a ball maybe here. Coming to the bat, exit the sketch. Now look that I only draw half of a circle, and then I'm gonna use this line to create the ball. And it's right there. But then I'm gonna create maybe a donut down here in the floor. Now look that for the donut, I can just create the entire circle and then one line of the axis. And there is my super big donut. Now the big difference was that, see, that in the donut I have the axis out of the circle, and basically I can define a distance from that axis and my revolution to make the donut bigger or smaller. No, I have to go back. Or in the case of the sphere, I have my axis inside the sphere. So your revolution axis can be, in the case of the donut, eccentric, or in the case of the sphere, can be embedded in the geometry. Just something to keep in mind when you're doing revolutions. So these two examples of the donut and the ball and the bat as well are just to show you how to do revolutions, and that will be part of your homework for this week. Well, first remember the submission rules. This homework will be due by September 13 at midnight this Sunday. Again, remember that any late submission is not accepted and thus will receive a grade of 0. Please, everyone, remember to submit both PDF with the screenshots of your progress. So if this was my homework, then easy. I just take a screenshot, I paste it in Word, and then I save this document as a PDF somewhere in my computer. PDF. Again, the file naming rubric that we discussed, L2, ABC123, homework 2, for instance, and maybe this is the first file. Save. And then you can have all of your screenshots in one one single PDF. So remember to create the PDF and upload it, but also remember to save the SolidWorks part file just by clicking here, Save As. Well, this was week 3. And again, the file naming convention, L2 ABC123. Well, in my case, it's LJK354. This will be the homework 2, and maybe the first file. And check that this one has SLDPRT, that's the file extension of this file. It means SolidWorks part. So you have to save and upload both. In case I cannot open your SolidWorks part, then I check the PDF to see your progress. But I cannot be certain that the geometry is correct in a PDF without any dimension. So that's why I have to check the SolidWorks part. So basically the same rules as the first homework, and then for this homework we have these two files. Basically here you have to create all of these shapes. Check that here we have some fillets here, 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 here. 8 of them with radius equal 4. And you will see those fillets in the geometry wherever you have these two parallel lines, because these mark the beginning and the end of a flat surface, or maybe of that arc. So be careful where you have those fillets. There are 8 of them, 1, 2, 3, 4, 5, 6, 7, and 8 here. You have these two arcs here. You have this circle, and then this corner and this corner, they don't have any fillet there. Remember that you don't have to have these center lines. These are just to locate the center of the circle. At the end, what I want you to have in your SolidWorks part is what I'm showing here on the right, the extrusion. And for the extrusion length, you can use whatever distance you want. I just want to see that if you are able to do an extrusion with those two holes in it. And then for the revolution, what I want you to do, well, you will have to create this sort of T-shape or pulley shape, and then you use this line in the bottom as axis for your revolution. And then instead of doing the entire circle revolution, I want you to do 3/4 of a circle. And at the end you will have this shape as final product. So you have here the blueprint and the final product for the extrusion and for the revolution. And you will have to upload 2 SolidWorks part files and maybe only 1 PDF file with the screenshots of the 2 activities. That will be the homework for this week. Sorry for the long video. Hope you have learned one or two things new this week. And please let me know if you have any questions via email or in WebEx during our lab time. Be safe, everyone.